Hi and welcome to the channel. This video covers the power distribution unit, or PDU for short. But before diving into ENERGIS project details, we need to understand what a PDU actually does. PDU stands for power distribution unit. The name describes what it is. It takes electrical power from a single input and distributes it to multiple outputs. Just think about what is under your desk right now. Probably a power strip. You plug it into the wall, then you plug the monitor, your computer, maybe a lamp into it. That is power distribution in its simplest form. A managed PDU does the same thing, but it does it better, and it gives you control over what happens at each output. In a home lab, this becomes essential. You are not just powering a computer and a monitor, you are powering devices, development boards, prototypes, all sorts of equipments. Each of these might need to be switched on and off independently. You might need to know how much current a prototype draws. You might need to power cycle something remotely while monitoring its behavior. A basic power strip cannot do any of that. A managed PDU can. A power strip gives you multiple outlets from one plug. That is all it does. Some have a switch, some have surge protection, but fundamentally everything plugged into it is either on or off together. You have no visibility into what each device draws. You have no way to control individual outlets. The managed PDU is different. First, each outlet can be switched independently. For example, you can turn outlet 3 off while keeping everything else running. This matters when you need to power cycle a specific device during a test. Second, a managed PDU measures power. It tells you the voltage, the current, and the power consumption for each channel. When you are developing a hardware, this information is valuable. You can verify that your prototype draws the expected current. You can detect problems before they become failures. Third, a managed PDU connects to your network. You can control it from your computer, you can monitor it remotely, you can integrate it with other tools in your lab. And finally, a managed PDU protects itself and your equipment. If something draws too much current, the PDU can shut it down automatically. These features transform a simple power distribution device into a piece of test equipment. Managed PDUs share a set of features. Usually they have a web interface for control and monitoring. You can access it through a browser. You can see the status of each outlet. You can turn on outlets, turn off outlets. You can view the power measurements. SNMP support for integration with monitoring systems. This allows you to pull the PDU from other software. You can log the data over time. You can set up automated alerts. Individual outlet switching. Each outlet operates independently. This is a fundamental to the managed PDU concept. Power metering. Voltage, current, and power measurements per channel. Some PDUs also track energy consumption over time. If the total load exceeds safe limits, the overcurrent protection trips. This might mean shutting down outlets or blocking new ones from turning on. These are the basics. Different PDUs implement them in different ways. Some add more features, some simplify. So what is ENERGIS? It is a managed PDU that I designed and developed over the past year. 8 channels, 10-inch rack format, per channel power monitoring, multiple remote access options. The idea came from a common problem. Most options on the market are designed for 19-inch racks, which is simply too large for smaller setups. I wanted something compact that could sit close to my equipment. It has local control from the front panel when I am at the bench, remote control over the network when I am not, serial access when the network is down or misconfigured. Keeping the cost low was a priority and released it as an open source project. If you want to build your own or customize it, you can definitely do it. But one important note here. This device works with mains voltage. Mains can kill you. If you are not comfortable working with high voltage, do not attempt to build this yourself. But seriously, get help from someone who knows what they are doing, or just buy a commercial unit. Don't risk your life. The unit mounts in a 10-inch rack, standard 1 unit height. The enclosure is made from aluminium. This 10-inch format works well with home lab scale. It is smaller than the 19-inch racks you see in a commercial environments, but it provides proper mounting and keeps your setup organized. Depth is about 176 mm. This fits in shallow racks without blocking airflow behind the unit. The AC inlet is where you connect the mains power. It accepts a wide range of input voltage, both 230 volt 50 Hz and 110 volt 60 Hz. This covers EU and US main standards. Next to the inlet is the fuse. This provides hardware level overcurrent protection. The fuse rating depends on the region, 10 amps for the EU, 15 amps for the US. The channel indicators show the state of each outlet. 8 pairs of LEDs, one for each channel. The green LED shows whether the outlet is on or off. The orange LED lights up when you select the channel using the front panel buttons. 3 navigation buttons let you control the PDU locally. Left and right move the selection between channels. OK toggles the selected outlet. It's simple and direct, no network required. 3 status LEDs show the system health. Error lights up if the PDU detects a fault. Lunch shows that the network connection is active. Power confirms the internal power supply is working correctly. There is also a power button. A long press puts the device into sleep mode. A short press wakes it up. Finally, the front panel has 2 connectors. A USB-C port provides serial console access and possibility for software updates. An RG45 jack provides the network connection. All connectors are on the front panel. This makes installation easier when the back of the rack is not accessible. The rear panel is straightforward. 8 C13 outlets. These are the standard connectors you can find on most equipments. The outlets are numbered 1 through 8. The numbers match the channel indicators on the front panel. Outlet 1 corresponds to channel 1. Outlet 8 corresponds to channel 8. Each outlet can handle the full rated current individually, but the total current across all outlets cannot exceed the inlet rating. That is the already mentioned 10 amps for EU version and 15 amps for the US version. Plan your loads accordingly. The most comfortable way to control ENERGIS remotely is through the web interface. The device has a static IP address configured by default. You can find it on the label on the bottom of the unit. Type the address into your browser and the interface will load. The control page shows all 8 channels. For each channel, you can see a label field where you can give it a name, something like DUT power or oscilloscope or whatever, so you know that what is connected there. You can see a toggle switch to turn the outlet on or off, and you can see the measurements, voltage, current, power, and uptime. At the bottom of the page, there are buttons to turn all channels on or off all at once. You can also see the internal temperature and the system status. The settings page lets you configure the device. You can change the network settings like IP address, subnet mask, gateway, DNS. You can set up the device name and location for identification. You can choose your preferred temperature unit. One useful feature is the configuration presets. You can save up to 5 named configurations. Each preset stores which outlet should be on and which should be off. You can apply a preset with one click. You can also select a preset to apply automatically when the PDU power is on. This helps with repeatable test setups. All settings are saved into EEPROM, so the data persists after power down. Once the configuration is successfully changed and saved, a short 3 seconds pop-up appears. ENERGIS also exposes metrics in Open Metrics format. This is the format that Prometheus uses. If you run Prometheus in your lab, you can scrape the PDU directly. Add it as a target. The PDU reports channel states, power measurements, system temperature, and more. From there, you can build dashboards in Grafana, set up alerts, all without writing custom code. For long-term data collection in hardware testing environment, this is very useful. For integration with monitoring systems, ENERGIS supports SNMP version 1. If you are running monitoring software like Nagios or Zabbix, you can pull the PDU directly. You can read out the outlet states. You can read power measurements for each channel. You can read system information like temperature and uptime. You can also control outlets through SNMP, turn individual or all channels on or off. The PDU uses private enterprise OID structure. All the details are in the automation manual, but the key point is that SNMP lets you integrate the PDU into whatever monitoring infrastructure you already have. The USB-C port on the front panel provides a serial console. Connect a USB cable to your computer and the PDU will appear as a virtual serial port. The serial interface gives you a command line access to the PDU. You can read and set outlet stage. You can view power measurements. You can configure network settings, check system status. This interface works independently of the network. If you misconfigure the IP address and lose network access, you can still connect via serial and fix it. The full command reference is also in the automation manual. For this video, just know that the serial console gives you complete control over the device without needing network connectivity. ENERGIS monitors the total current draw continuously. If the current gets too high, the PDU will take protective actions. It will shut down the most recently activated outlet. It will block turning on additional outlets until the current drops to a safe level. This protects both the PDU and your connected equipment. This is not a substitute for proper load planning, but it provides a safe margin if something unexpected happens. You can check the overcurrent status through web interface, SNMP or serial console. If the PDU enters a lockout state, you can reset it manually once you have reduced the load. That was ENERGIS at a high level, what it does, what it looks like, how you interact with it. This video was an overview, the next videos go deeper. Part 2 will be a low-level deep dive into the hardware. We will go through the schematic, every submodule, the datasheets, the PCB design decisions and layout. Part 3 covers the embedded development, all the code running on the system, firmware architecture, how the different interfaces are implemented. Part 4 is testing. I will show my universal test framework and demonstrate how the hardware validation is done. If you want to follow along with the build, the links to the project repository are in the description. Thanks for watching.